the new paradigm is kind of these instruction-based models where you can kind of tell the model what you want to do, and it'll do exactly what you ask it to do. But that's harder to do than one might think, because you have to train the model on these instructions. You can't just train the model on a bunch of text. So there's two steps. The first step is you have to train the model. So maybe you create a base model like GPT, DaVinci, and then you have to fine tune the model on this instruction data. And the initial, and then you get a model like ChatGPT, which follows instructions a lot better than the original base GPT model. Now, the initial training is really easy. You can just scrape the internet, and you have this model that's full of knowledge. So you have this massive data set here, and you train your model. Maybe this is your GPT model, and this is your internet. And you train your GPT model on this, and you get a really good model that knows a lot about the world. But you may ask it to, maybe you ask it, I want you to write me some code to do, I don't know, some task. And maybe instead of it actually writing you code to do some task, it responds with the code should be blah blah blah, and it just takes what you had and then adds something else. Maybe it extends the question. It's like, well, that's not what I wanted. I wanted you to respond to it. So that's where the instruction fine tuning comes from, where you get this instruction response data set, and you have to get these from humans because, well, at least the current way you do it is you get them from humans, and that's expensive. But this paper also claims it's not very diverse, the human data. So it may be really good data, but it's not diverse, and it's really expensive to obtain. But what if you don't have a ton of money to do that? And what if you want to automate this so that you don't have to have a bunch of humans doing this, so that it can be maybe a better data set and a whole lot cheaper? So WizardLM is a model that attempts to do this. There have been other methods where you kind of like take GPT-4 and you take some data from it and you just train on that, and or maybe you do some like knowledge distillation with GPT-4. But this method is different, and it's a pretty interesting method. It's one of the first I've seen that really kind of does this data set creation automatically. So it's a very interesting method, and they call their resulting model WizardLM, and I think they call their method for creating the data set Evol-Instruct. So they kind of have two goals in this paper. The first goal is to auto-create an instruction data set. So this is assuming you have a base model, which is a good assumption because you have models like Llama. So you can take Llama and that's your base model. But they want to make it a good instruction model. And there is Instruct Llama, but they want to do it differently. And Instruct Llama was created on human data. They want to do this automatically. So they want to create this automatic instruction data set. But additionally, they want to make the data set more complex and different than the human data set. So they want to make like one of the biggest problems with the human data sets is like besides the cost is that they're not very complex, and like they're not very difficult. They're easy tasks, but they want to try to make it more complex tasks. So the main thing with this paper is creating this data set, and then they train a model called WizardLM on that. And WizardLM is actually a pretty good model. You should try it out. And I think that the new code model is supposed to be really, really good as well. So yeah, just get into it. So to start, let's assume we have a data set with like some base instructions, and they make this assumption because you have to start with something, and the data set they start with is Vicuna. So you have this Vicuna data set. Let me move this right here. get to that in a sec. So you have this Vicuna dataset here. This is Vicuna. I think it was Vicuna. And this has some instructions in it. Maybe it's like 50, I think it's 52,000 instruction response pairs. And so you have this data set and you have instruction and response pairs. So maybe the instruction is write me some code to do something, and then the response is here's some code to do whatever the heck you wanted to do. So you sample an instruction from this data set, and what they want to do is evolve this instruction in multiple ways. So they do this with two things. They do this with Indepth Evolving and Inbreath Evolving. The blue arrow is Indepth, and the red arrow is Inbreath. So in Indepth is kind of like changing the current prompt by adding, I guess, constraints to it in a way. So, I mean, they show here you have this plant in a beaker and you change it to this scene here. Maybe it's a growing tree or something like that. So mutating this, maybe you have some oak tree. Maybe this is an oak tree. And then Indepth Evolving would be, I guess, growing the oak tree. So it grows a little bit. So it's the same base. You still got this oak tree, and it's just grown a little bit. So a little bit, and that's the Indepth. And then it grows a little bit more. So it's still the same oak tree, just I guess different constraints in a way. But let's say you do an Inbreath Evolving and it turns into a palm tree. So it's the same idea. It's still a tree, but it's a different type of tree. So there's a shift there, and then maybe this tree is on a beach or something like that. However, the instruction evolving can be bad. So say we do an Inbreath Evolving and it kills the tree, then this is a path mutation and you want to get rid of that. So along the way, you have to figure out which instructions are bad and get rid of those. And the instructions that are good, these instructions here, you throw them in the instruction pool, which would be the Vicuna dataset, and you can resample them to evolve those instructions again. Now, once you have this instruction pool, after you've evolved it, what they do is they take the base Llama foundation model, and they train it to create what they call WizardLM. So basically the idea is you take this initial instruction and you make two types of you can do two types of variations, which they do at random. And the two types of variations are you can stay in the same domain, so maybe that's like coding or something like that, and change the instruction slightly in some way where maybe you add some constraints to that problem, or you can drastically change it so that it's in a different domain. However, you mutate the instruction in a way, but we'll see how this actually works in theory. And this is what they do, but that's the general idea. So if I go down here, we can see how they do this in-depth evolving. So we start from an instruction, and we have to evolve this instruction somehow. And let's just start with in-depth evolving. So we need three things. We need to figure out how to do this in-depth evolving. We need to figure out how to do in-breadth evolving, and we need to figure out how to kill the instructions that are bad. And this is assuming we have a base instruction that is pretty good. Maybe that is write me code to do whatever. So let me hit this. In-depth evolving enhances instructions by making them more complex and difficult through 5 steps of prompts. Add constraints, deepening, concretizing. I cannot speak. Concretizing, increased reasoning steps, and complicated input. So they have these 5 different methods to change the prompt a little bit. And they say the core part of the in-depth evolving prompt is this instruction here. Your objective is to rewrite a given prompt into a more complex version to make those famous AI systems e.g. ChatGPT and GPT-4 are a bit harder to handle, but the rewritten prompt must be reasonable, understood, and responded to by humans. That's just the top prompt that they have. And I guess the best way to kind of show this is to give an example. And we'll go through an example for each of the 5 that they have. So this is an example for add constraints. So you have this prompt, this initial prompt, whatever that may be, and you want to add constraints to it. So the prompt starts off with, I want you to act as a prompt rewriter. And then you have the base prompt, which we set above, these 3 lines. And then they say your rewriting cannot omit the non-text parts such as table and code, the prompt parts given with the hashtags, and then also please do not omit this part. So they're really trying to convince it not to rewrite the initial prompt, the given prompt, because that would be, or they're trying to make it not rewrite the initial prompt and this part here, which signifies the initial prompt. So then this part here is the actual add constraints part. You should complicate the given prompt using the following method. Please add 1 or more constraints/requirements into the given prompt. And then they also add this. You should try your best not to make the rewritten prompt become verbose. The rewritten prompt can only add 10 to 20 words into the given prompt. And they say that they add the 10 to 20 words part to control difficulty increase. We make each evolution a bit harder and restrict adding a maximum to 10 to 20 words. So it doesn't allow it to go crazy with the output it generates. That's why I have the 10 to 20 word constraint. And then you give it the given prompt, the rewritten prompt, and they say that you shouldn't repeat given prompt and rewritten prompt. And then you give it the rewritten prompt, the given prompt, and like you give it these hashtag things telling the model what is going to be below and what this part of the text, what this part of the prompt is. And then you give it the given initial instruction, and then you tell it to write your rewritten prompt. So that's all this is doing. But the important part is please add more constraints requirements into the given prompt. So this is what you give whatever your model may be. And in this case, they use ChatGPT. I think they use a GPT. It may be DaVinci, but they go through the OpenAI API, and they either use DaVinci 3 or ChatGPT or GPT 3.5, whatever the model they have, the best model they have on the API right now. Except not GPT-4 though. they don't use that. And you give it this, and then it takes your old instruction and it changes it to the new instruction based off this. So based off the add more constraints and requirements. So this is just telling it add more constraints and requirements, and it'll do that, hopefully. Which is why we have the check mechanism, which we'll get into in a sec. So now we have the deepening prompt, and the deepening prompt changes this part here. If the given prompt contains inquiries about certain issues, the depth and breadth of the inquiry can be increased. So all this is saying, like if you have some question, then increase maybe the context or something like that about the question. So it's just adding more info about like a certain question in the prompt. Concretizing, I think that's how you say it. Please replace general concepts with more specific concepts. So I mean, this is pretty basic. You're just kind of going deeper into any of the concepts that may already be in there, just adding more context to that. It's different from this because this is specifically like a question up here. This is specifically a question and expanding on that question, and this is going more in depth into a certain concept, but they're similar. Increased reasoning step prompt. So this one says if given prompt can be solved with just a few simple thinking processes, you can rewrite it to explicitly request multi-step reasoning. So Maybe this is like think step by step, something like that. But it's basically if you have this problem that can be solved like easily, maybe that's like 1 + 1 = 2. Actually ask it to think or add to the prompt to force it to give or like show its steps, show its thinking as it generates this output, as opposed to just generating the output directly. Now the last one, if I go all the way back up here, which is a little more complicated, no pun intended, for complicated the input. So this one's a lot longer, and this is the fifth one, the fifth and last one. It's so you have the space prompt here. That's just the normal prompt that you have. And they give it a few examples. So maybe the prompt is you must add XML data format data as input data to the rewritten prompt. So you have this prompt and you want to add XML data to it, and you have some XML data to. I'll show you an example in a sec that they have at the end. But they give it a few examples here of it of old. Like here's an instruction, here's a rewritten prompt, old complicating input examples, because I guess they found it wasn't good if you did zero or if you did this in zero shot, and instead they had to make this a few shot problem. So you have to give it a few examples, and then you tell it, this space prompt here. And then in this case, this in-depth addition is you must add whatever data format, data as input data to like the written prompt. So you must add some whatever data format that is, maybe that's XML data, format data as input data, add the given data format, so the XML data, code as input code in the rewritten prompt. So this is adding some data to the prompt. And then it says rewrite the prompt like it must be a question style instruction, because I guess they want to keep it as a question. So I mean, this prompt is a little complicated, so let me just show an example. I thought this example here was good. So you have the space prompt here. That's just what they've had before. And in this case, they say you must add the HTML page format text as input data to the prompt. So this is the old prompt. This is the initial prompt that was evolved before. And this is the first example that you show the model for your few shot learning. So that's the given prompt. Scroll through the whole HTML page. So, I mean, you want to complicate that a little bit. So the model before, maybe this was the model. This was an old complication it did, where it turned scroll through the whole HTML page, and instead you have to add HTML page text to it. It created this thing here. So it says I want to be able to scroll through the whole page, but without the scroll bar being shown. And then they say, here's how you do it in Chrome, here's how you do it in Firefox, and whatever. They the model added all this, and it's asking the same question, but it's not, or it's basically asking for the same thing, but it's not bad. It has a lot more context to it, and it added the HTML page format text in here. See, right here and right here. So that's the first example you give, and you can give it other examples here, and then you tell it, then you give it whatever prompt you need. So this would be like one of the few shot examples. This would be another one of the few shot examples. And in this example, it complicated this prompt to this prompt here. And so you would just give this as an example for one of the future prompts whenever you're trying to complicate it. But this is an example of how it may complicate it. There's a few more examples like that, but that one was my favorite, where I think that one really shows how you can complicate it pretty easily and how it can do a good job with that, assuming that the output is actually valid. So those are all the in-depth. Now Inbreath is pretty easy. It's a lot easier than that. Indepth Evolving aims to enhance topic coverage, skill coverage, and overall dataset diversity. Open domain instruction, fine-tuning datasets such as Alpaca, ShareGPT, etc., are typically small in scale, lacking topic and skill diversity. To solve this problem, we designed a prompt to generate a completely new instruction based on the given instruction. So the instruction looks very similar, but the important part is this new prompt should belong to the same domain as the given prompt, but be even more rare. So you're giving it some prompt, you're giving it an instruction, and you're telling it to evolve it, but specifically you tell it to evolve it such that the given prompt, such that it's the same domain as the given prompt, which was the tree above, but even more rare. And I guess they found that this prompt worked to change the kind of mutate the prompt a little bit, or mutate the instruction a little bit. So that's how they do the in-depth. And finally, we need to have this elimination evolving. So you need to know what instructions worked well and what instructions did not come out well. So they have 4 parts. The first part is basically if the new prompt is the same as the old prompt. So if the evolve instruction does not provide any information gained compared to the original one, then you remove it. So why would you add the same thing in your dataset twice? And that would just be kind of useless. The second one is if the LLM cannot respond. So if ChatGPT cannot respond to the prompt well, given the new instruction, then you want to remove that. So the evolve instruction makes it difficult for the LLM to generate a response. We found that when the generated response contains sorry and relative short length, i.e. less than 80 words, it often indicates the LLM struggles to respond to the evolved instructions, so we can rule this out to make a judgment. And 80 words is probably like an upper bound just to ensure that they don't have garbage data. Now, the third one is if the LLM response is trash. So like whenever you generate an instruction, you have to have the LLM create a new response for it. But if that response is bad, then you want to remove it. So the response generated by the LLM only contains punctuation and stop words. Then it's garbage output, and you just remove the instruction and the response. And you don't want to add that to your database or your dataset. And finally, if the LLM just copies the prompt, like literally copies the prompt. The evolve instruction obviously copies some words from the evolving prompt, such as quote given prompt, quote rewritten prompt, or quote hashtag rewritten prompt, etc. So these are the 4 ways that they automatically remove garbage generated instructions. Now, putting this all together, we can go through this method thing I wrote up here. So if you have a dataset D of instructions I and responses R, then you can evolve this dataset by iterating over, so you have some number of epochs, which is the number of times you want to evolve your entire dataset. And for instructions, so for the current instruction in the dataset, so for some instruction in the dataset, IT, T is the time step, I guess. You evolve the instruction from IT to IT plus 1. So that may be your in-depth evolving or maybe in-breadth evolving, whichever method. You can randomly choose that. Then check if IT plus 1 is a bad instruction. So if it's bad, I guess this part would actually go after this part. So I'll leave it. So generate a response RT plus 1 by prompting the model with IT plus 1. So you need to generate a response to this new instruction. There's not going to be a response because it's a brand new instruction. So then after you generate the response, then you can check if it's a bad instruction, because you need to know if it's part of the bad instruction was the response garbage. And finally, if you have this generated response, this generated instruction, and it passes your checks, then you put it back in the data set. And in the next epoch, you can then evolve that new instruction. And that's what they have here. So that's their method. That's what they do. And they have this example up here. So maybe this is your initial instruction. 1 plus 1 is equal to unknown. And they have a bunch of examples of how it may evolve. So increase is reasoning. Maybe it evolves to what is the value of x if you have this system of, or if you have this algebra equation. So that increases reasoning, I guess, for the model. Deepening, in what situation does 1 plus 1 not equal to? Yeah, there's an example of deepening, concretizing. If you have one apple and somehow it gives you another banana, how many and someone gives you another banana, how many fruits do you have? I'm guessing these are just examples that they pulled from their data set. Add constraints, how to prove 1 plus 1 equals 2 in the Goldbach conjecture. And complicate input, yeah, complicates it, definitely complicated. And then in-breath evolving is what is the speed of light in a vacuum? So like that's clearly a different domain. It's not all the in-breath ones were in the same domain, like I guess kind of algebra-ish, while this is physics, so different domain, and that's your in-breath evolving. And I don't know, maybe the LLM somehow got here. Whatever the LLM thought it got here. Yeah, and maybe, yeah. So in this case, they complicate the input with a formula. In this case, they complicate the input with code. So that's the last one I showed, where it makes it a little bit more complicated by maybe adding HTML context or something like that. So this one adds some context or whatever to the formula. I mean, it was already a formula, so they complicated it by adding more numbers. And then complicating it with code is converting it to code, I suppose. Yeah, so what is the speed of light in a vacuum? Deepening, how is the speed of light in a vacuum measured and defined? And increase reasoning, how many times faster is light than sound in a vacuum? So just different questions, but in the same domain. And then in-breath evolving one more time converts it to chemistry, so a different domain. While in the same domain, maybe you add a table to complicate the input. So those are some examples that they give. You can kind of see you want to stay in the same domain and kind of complicate the input a little bit, evolving it in ways to kind of ask different questions, and then you want to somehow get to different domains that were not in your data set, and that's your in-breath evolving. So now that you have this data set, you can just fine-tune Llama on there, and you get WizardLM. And I think it's interesting to look at a few of the results that they show for WizardLM. Specifically, this one is interesting. So it's really small, but if we look at the Evol-Instruct dataset, the test set, which is the dataset they create, then you can see that ChatGPT wins more times than it loses. So yellow is lose, green is win, and you can see ChatGPT wins more than it loses compared to WizardLM. But in the cases of Alpaca and Vicuna, WizardLM beats the Evol-Instruct model. And it's the same story on the Vicuna dataset. Alpaca is a little worse than WizardLM. Same with Vicuna. Vicuna is a little worse on the Vicuna dataset than WizardLM, and then ChatGPT is a lot better than WizardLM, as you can see by the scores. And then on high difficulty dataset, they make this an important note that ChatGPT actually does worse than WizardLM on the high difficulty dataset. And then, yeah, it beats the other ones as well. So overall, WizardLM is a pretty strong model according to these results here. And then One last result I want to show, there were just a couple that I kind of thought were pretty interesting, is the topics that it does worse and better at than GPT-4 or than ChatGPT based off the GPT-4 score. So this here is human, sorry, this here was this human? Yeah, this here was human evaluations on the Instruct test data sets. This is GPT-4 evaluation on all the skills. So if we cut it off here, so this is 100%, and if we look at the y-axis, this is WizardLM over ChatGPT. So this is how much better is the WizardLM score compared to the ChatGPT score. And this is where it does better than ChatGPT. And it does better in philosophy, technology, physics, and ethics, which is kind of interesting. Yeah, that's just what some of the results, and it's about equal in a lot of areas here. And this is on the Evol-Instruct test set, but specifically what it does significantly worse at, I marked here, is kind of like reasoning tasks, reasoning and coding. So it directly does really bad on reasoning. Coding and debugging, code generation, computer science. It doesn't do well at multilingual because I wouldn't imagine it would do well on multilingual. I doubt that going in breadth or like going to a different domain will go to a different language. You probably wouldn't go to a different language. You probably have to prompt that directly to go to a different language. So I wouldn't imagine this would be very good in how they construct their data set. I guess it's not good at common sense or art or common sense art. I'm not too sure about this one. And then complex format, I do not exactly know what that is either. But yeah, it's not that good at like reasoning and code generation, which is kind of interesting. And remember that ChatGPT kind of constructed this data set. So it's interesting to see that this in-breadth, in-depth search does really well, but it does bad at a few things like code generation and reasoning. There's some other results, but I think those are the most interesting. They also have the scatter plots, which kind of look cool. I guess what they're showing here is that they have more dots in here. They're C1 and C2, C3, and C4. It feels more space in the PCA. I'm guessing this is PCA. And yeah, I mean that's the paper. It's this way to automatically construct a data set, and it does pretty good compared to all the other human trained models, which is very interesting. I'm curious to see where this method goes in the future. I really think it'll be I really think it'll be great to have model, or we're kind of moving towards a paradigm where models train models, where models are creating the data and they're training models on that data. And it's kind of cool to see that it does well and the output isn't super bland if you do it right. So very interesting. And yeah, that's WizardLM. I would try out WizardLM. It's a pretty cool language model. Yeah, and I think they even released a second version for Llama 2. But there we go, WizardLM.